Good morning, my students. I want to welcome you to today's lesson. We are going to be looking at factor formula today, and we shall take quite some reasonable time as programmed to ensure that we effectively understand this. Before I start, I want to try out one number with you on what we discussed yesterday, just to be sure that we all know what to do. And today is the 21st. Today is the 21st of May. We want to thank God for the gift of life and pray that He continues to guide us. Let us just look at this number, and shortly after we can move to factor formula. I will selectively pick a number that is number 4 on 17D. Number 4. Number 4 says that we solve the expression is cos theta minus 7 sin theta is equal to 2. And they're telling us to solve for theta within the range of 0 to 360 degrees. I told you for equations that have the right hand side, those ones will require you to solve. And for equations where they want you to find the maximum or the minimum, they should not be equations. They should not be equations. They should be expressions. They should not have an equal sign. Number 2, I told you that once you notice that on the right hand side you have a sign, then you can predict that that expansion is a cosine expansion, especially if you have a cos on the left hand side. And once you have a sine on the right hand side, on the left hand side, then definitely that must be an expansion of a sine. So we shall assume that this is a cos expansion, and if we assume that it is a cos expansion with this minus, it implies that it is an addition. It is a cos addition. So we shall consider the addition of the cos of say a plus theta. If we consider that expands to give us cos of a, the cos of theta, minus sine of a, the sine of theta. Now, if we look at this and compare it with what we have, it would imply that if we compared this with the upper one, it would imply that we have a coefficient here of 1, which is silent. It would imply that cos A, cos theta, is equivalent to cos theta, implying therefore that our cos of A would be equal to 1, because this would cancel or would be divided through both sides. And also sine, the other hand side, the right hand side, sine A, sine theta would be equivalent to 7 sine theta. I am eliminating the negative because the negatives would cancel. And this would imply also that our sine of A is actually equal to 7. If we labeled these equations as A and B, dividing them, and specifically B by A, so that we just get tan, which is easier, we get left-hand side giving us tan A, which we obtain from sine of A over cos of A, for those who may want to ask where is tan A coming from. And sine of A is 7, and cos of A is 1. So it implies that our tan of A is 7. And therefore, our A can be obtained from our calculators by taking the tan inverse of 7. Now, on my calculator, and as you try your calculator, we are interested in getting the angle whose arctan is 7, but ensure that your calculator is in the degree mode. And it is only the tangent. That has figures that go beyond 1. Should you get a cos or a sine and it is giving you like sine of A is equal to 7, that will not be possible. So after getting a value of A, we need to also look at if our cos of A is equal to 1 and our sine of A is equal to that. It means that if this is A, cos is adjacent over hypotenuse. Sine is opposite over adjacent. So we need to find the hypotenuse so that we get what is here and what is here. If cos is 1 and sine is 7, the other one is that, how are we going to handle the other bit to be able to get what is required? So if this angle is A, sine A is opposite over the hypotenuse, and it is telling us that sine of A is 7. Of course, this is a bit strange, and we want to find out if we are getting that the tan is this, tan is opposite of adjacent, cos is 1, then this would be 1, 1. 1, 1. Cos of A is adjacent over hypotenuse, and that cannot be possible. Sine of A is opposite over hypotenuse. So if this is 7 and this is 1, which is impossible, we need to review this triangle again. If I look at this the way it is, I can consider an expansion, just the left-hand side alone. If you consider the left-hand side alone, and you say you have that expression, then it would mean that our cos of theta minus 7 sine of theta, if we just look at that alone, is equivalent to some constant which I could put there on our original expansion into cos A cos theta minus that constant into sine A sine theta. So if I picked my k cos of A and I equate it to 1, and k sine of A and I equate it to 7, by squaring, my k squared would be equal to 50. To be 1 plus 7 squared. So the k will be equal to the square root of 50. Now if I use that approach, it means that my expansion, which is this root of 50 into the cos of my A, which I can take as our 81.7 plus theta, should be equal to 2. So I want to get the values of theta. So it means my 81.87 plus theta should be equal to 2 out of root 50. And the cos, and therefore 81.87 plus theta should be equivalent to the arc cos or cos inverse of 2 out of root 50. And because this angle is very big, this angle here is very big, we are going to look for very many angles here because of our range. Using that, since this is a positive, it means we are looking at this first quadrant and fourth quadrant. So we get the first value of theta. I will write this plus theta being equal to, the first value is the arc cos, second function shift or shift inverse of 2 over the root of 5 of 50, sorry. And we get our first angle here will be 73.57 degrees. Now the next angle will be 360 less by that angle, and that will be 286.43 degrees. Now the next angle should be 360 plus the first angle, 360 plus 73.57 degrees, which will give you 433.57 degrees. Now the next angle would be 720 minus, but even when we take off this on from the resulting angle, we'll get an angle that is still greater than 360. So we'll stop here and look for theta by subtracting. The first value will be a negative. If I start with this last one, I take off our 81.87. I'll get my first angle here as 351.7 degrees. And my next angle will be 286.43. I take off my 81.87, and this will give me 204.56 degrees. And of course the other one is that negative angle, which we can just write before we conclude, and that will give us negative 8.3 degrees. So conclusively we say our values of theta should be 204.56 degrees and 351.7 degrees. That should be the solution for number 4 of exercise 17D. That should be the solution for number 4 of exercise 17D. Using several other methods, you can be able to try out the other numbers. Yes, 204 point that and this. Of course, if you have your backhouse, number 4, for emphasis, the angles are there, 204.6 and 351.7, which is in agreement with what we are getting. With that warm-up, we can move the factor formula. We can move to the factor formula, and we are slowly but surely moving deep into the area of trigonometry. Factor formula. Factor formula. I'm using backhouse 1, but like you're aware, there are several textbooks of pure maths, several, and I've shared them with majority of you here. Now, under factor formula, what I want you to remember, or what we are going to use, we should be able to recall all the expansions. We should be able to recall all the expansions that we looked at. And we shall start with the cos of A plus B. The cos of A plus B is cos A, cos B. If it is a cos expansion and we have a plus, it becomes a minus. Minus sin A, sin B. You can call that equation 1. The cos of A minus B will give us again cos A, cos B, this time plus sin A, sin B, and this will be equation B. Now, factor formula looks at the addition of these functions. If we add, we are working together, not me. If we add equations A and B, the left-hand side will give me cos of A plus B plus cos of A minus B. I hope we are together. That's what I get on the left-hand side. But on the right-hand side, I want you to notice. I will write everything, try to squeeze it here. Cos A, cos B, minus sin A, sin B, that is the first part of equation A, plus the part of equation B now. Cos A, cos B, remember I'm adding, minus sin A, sin B. What happens? I'm zooming into our right-hand side. You notice that minus, the first part is minus, the second part is a plus. This is the first part, and this is the second part. But since we are adding, this and this are additive inverses, so they will cancel. They will cancel. And what do they leave us with? Cos A, cos B, cos A, cos B, and we are adding. It's like xy plus xy. What do we get? We get 2xy. So it means we shall get that the cos of A plus B plus the cos of A minus B, for now, as 2 cos of A cos of B, for now. I don't want us to confirm this as the factor formula yet, but this is it anyway. This is it anyway, but we shall simplify it shortly. So that is what we get. And after looking at this, there is a short exercise that they challenge you with. There is a short exercise they challenge you with, but we can look at this short exercise after subtracting. If we subtract A minus B, what do we get? We get cos of A plus B, and we are taking away now cos of A minus B. What do we get? I repeat by writing everything here. Cos A, cos B, minus sin A, sin B. Remember we are subtracting this time. Minus cos A, cos B, plus sin A, sin B. I zoom in close. If we open these brackets, this is a minus, and this will become a minus as well. So if we open the brackets, we shall have cos A, cos B, I'm going to correct like terms, minus cos A, cos B, they are corresponding. Then minus sin A, sin B, then minus sin A, sin B. You will notice that this term will cancel with that term, and that implies that our cos of A plus B minus cos of A minus B, because we are subtracting, is going to give us minus 2 sin A sin B. It's going to give us that. Now these are apparently the factor formula for cosine. That when you are adding two cosines, you get two cosines. 2 times cos. Cos A plus B plus cos A minus B is 2 cos. but cos of A now and cos of B, not the minus and plus. Cos A plus B minus cos into A minus B is minus 2 sine, but sine of A and sine B. And like I said, there are questions here. If you go to the textbook, there are examples. I'll simply pick out 2. They are saying express as a sum or difference of 2 cosines. As a sum or difference of 2 cosines, and they give you like 2 cos x cos y. It implies that this is a sum of cos into x plus y, since it is cos plus cos of x minus. This is what they want. They can give you a number like minus 2 sine of s plus t sine of s minus t. If it is minus, notice one thing. It must have been a subtraction of 2. And this is a cos, of course, of what? If it is s plus t that they are getting in here, it means that, look at this. This is x, this is y. But here we are saying x plus y and x minus y. So it means if this is this, you add these 2. When we add, it means it is the same as the cos of 2s minus the sine of 2t. Minus the sine of 2t. If it is written like this. We will find out why I'm saying it is like that. If it is single, we make it half. It is this plus y. If I say this, it is when I will get cos x cos y minus sin x sin y plus cos x cos y, which will give us the 2 cos x cos y, and the other one will go away. When I have this, it should be, if it is s plus t and s minus t, we are supposed to add them. And when we add them, we get 2s, and the t goes. When we subtract them, we get t minus minus, which is 2t. So that would be an example. Those can guide you in that oral exercise. If we consider another example, let us consider one more. C. If they say 2 cos of A plus B over 2 and cos of A minus B over 2, what expansion are they looking at? They are looking at an expansion. This should have been a, let me say, 2s. This is cos of 2s plus 2t minus, it was sin minus cos of 2s minus 2t. If you consider this, and they're saying, how do we express it as a sum or difference of 2 cosines? If it is cos, first of all, it is a cos of that. Cos, yeah, it means that you are adding. It means you are adding plus cos of another angle. Now, if it is a plus b over 2, we get this by looking at, like I told you, that this, if it is a single angle, you look at the addition of those angles. Now here, when you add them, you will get what? You will get a over 2 plus a over 2, which is a. and it will be that and this. It will be A plus B, the cos of A plus the cos of B. Just like that. As we shall shortly see, if we have half, then it is separated into double angles of each. Now, let's look at expansions of sine. Sine expansions. Sine into A plus B. Sine into A plus B is sine A, cos B, if it's a plus, it stays as a plus, but we interchange the angles and the trig signs. You can call this C. And then sine into A minus B is again sine A, cos of B, but this time minus cos A, sine of B. Similarly, we shall add and then later subtract. When we add our C plus D, we shall obtain plus the sine into A minus B. When we add the right hand side, we have sine A cos B plus cos A sine B. We are adding, so plus sine A cos B minus cos A sine B. Since we are adding the right hand side, you will notice that this cos A sine B, this last term, will cancel with this one. This is a positive, that one is a negative. You can see this negative. But this is like xy plus xy. So it will give us 2 sine A cos B. And you can comfortably say, therefore, that the sine of A plus B plus the sine of A minus B will be looked at with factor formula to give us that. Will be looked at to give us what you are seeing there. We shall move to another page and look at the subtraction of the two expansions. The subtraction. We are looking at the subtraction of the expansions of sine. Subtracting our sine of A plus B minus sine of A minus B will give us, we are subtracting D from C, will give us sine A cos B plus cos A sine B minus, I'll put a small bracket here, sine A cos B minus cos A sine B. After subtracting this, if we open that bracket, our right hand side will give us sine A, the cos of B, plus cos A, the sine of B, minus sine A, the cos of B, plus this minus becomes a positive. This minus here times the minus becomes a positive. So we have plus cos A sine B. This time it is this term that cancels with that term, because it is sine A cos B minus sine A cos B. So our right hand side will stay with the 2 cos A sine B, as you may see. This is cos A sine B and this is cos A sine B. So it becomes 2 since we are adding. And this means that we are saying that our sine of A plus B minus the sine of A minus B is equal to that. gives us that expression as a factor formula. Now, these are 4 expressions, and similarly, we can also have some selected examples under here. It is still an oral exercise that they are testing you with. If they say express as a sum of sine, express as a sum or difference of sine of two sines, and they give us like 2 sine x cos y. This would definitely be equivalent to the sine of x plus the sine of y. If you add the sine of 2x, sine x plus sine y, that will give you a half. But if you are saying it is 2, it is the sine of x plus y plus the sine of x minus y. This is what gives you that. It's supposed to be oral. I'm saying it is the sine of x plus y plus the sine of x minus y. If you want to cross-check, you are supposed to expand the right-hand side to see, does it give me this? You cross-check by saying this is sine x cos y plus cos x sine y plus sine x cos y minus cos x sine y. You notice that this and this will cancel, and this gives you 2 sine x cos y indeed as required if you are cross-checking. The other part they want us to cross-check is they have given you like 2, the sine of 3 theta cos of theta. They want you to express it as a difference or the sum. If it is sine cos, it is always an addition. If it is cos sine, 2 cos sine, it is a subtraction. But if it is sine cos, it means you are looking at the sine of 2 angles. Sine of 2 angles added up together. And if we are having 3 theta and theta, it means these are all theta and theta. It means they are telling you which 2 angles do you add up to get that. The sum of these 2 will be 4, and the difference of these 2 will be 2 theta. So ideally, the interpretation is that you say it is 2, the sine of 4 theta plus 2 theta over 2, the cos of 4 theta minus 2 theta over 2. And this is what gives you 2 sine of 6 theta over 2, which is 3 theta, cos of 2 theta over 2, which is theta, which is equal to the left-hand side. That is like a proof. I also try out one more. That means that I will be leaving you just a few to try out. They say 2, the sine of r minus s out of 2, the cos of r plus s out of 2. I said as long as we have sine cos, the expansion must be a sine plus a sine. If we have cos sine like this, 2 cos of say x plus y sine of x minus y, then this must definitely be a sine subtraction of 2 angles. This is a sine addition of 2 angles. So orally, you are being asked to, if you have this, what should it have been here? What should it have been here? And you will discover that to get that, usually you should have numbers of that nature. To get this, if it is cos x plus y and x minus y, it means when you add, you get 2. And it is 2x plus 2y, and then 2x minus 2y. That we can get to know. So in summary, with what we are looking at, I want to write this, and this should make you understand. We have been able to see that if we add two cosines, a plus b and a minus b, we get 2 cos a plus b. We get 2 cos a cos 2 cos a cos b. I hope this is clear. If we have cos of a plus b minus cos of a minus b, we've seen that we get minus 2 sin a sin b. And if we have sine of a plus b plus sine of a minus b, we've said that we get 2 sine cos. And we say also that if we have sine of a plus b and we take away sine into a minus b, we get 2 cos of a sine of b. Now we want to generalize these and come up with what we would call the identities. If we let a plus b be p, you can call this equation I, and a minus b, let me put it here, a minus b be q, we call it equation 2, then by adding these equations, we will have a being equal to p plus q, 2a, implying that a would be p plus q over 2. Let me use small q. I hope we are together. By subtracting, we are subtracting 1 and 2. If we add them, this dies. By subtracting, we shall get 2b this time. The a dies, but this becomes a plus. We get p minus q, implying that our b is p minus q over 2. I want to repeat that if we let the sum of a and b be p and the subtraction of the difference of a minus b be q, then if we here, which is p plus q, and our a would be that. And if we subtracted, I would get 2b, which would be equal to this, and our b would be that. Now I want to substitute for a plus b, for a and b there, with the letters they have given us on the left and on the right. So here I'm going to be having p where there is an addition, and I have q where there is a subtraction, and where I have a, I'll be putting there these ones. So summarily we can say, if I substitute, we are here saying that the cos of p plus the cos of q is equal to 2 the cos of p plus q over 2 the cos of p minus q over 2. And we will read this as cos plus cos without mentioning the angles, but you know that the cos P plus cos Q is 2 cosine semi. Semi means a half. Semi sum. Sum means addition. It is 2 cos semi sum cos semi diff. Diff for difference. Cos of P minus cos of Q becomes 2 sine negative. Sine semi sum. Sine semi sum. Sine semi diff. That's how we read it. Sine semi sum. Semi is a half of the sum. Sine semi difference or diff. Then sine of P plus sine of Q is 2 sine semi sum cos semi diff. And then sine of P minus sine of Q is 2 cos semi sum sine semi diff. Now these expressions are the ones that ultimately will give you a clear interpretation of the factor formula. However, the factor formula is already exclusively stated even in the previous expressions. We have simply substituted for these to get that. And at this stage, we can try out some examples. We can try out some examples and eventually we will come to the end, leaving you with some questions to try out. So examples. We have finished the derivations needed. Examples and number one. They tell you to solve the equation. The equation is sine of 3x plus sine of x is equal to 0. And they want values of theta to be in the range. It's values of x now of negative 180 and positive 180. Solve, the number is there. The solving, apart from this now being the factor formula use, would be the same. That is sine plus sine. That's where you see that you need now to use factor formula. Numbers of this nature would either be cos plus cos. You look at the angles. So sine of 3x plus sine of x, using the addition of the factor formula of sine, it tells us that we get 2 sine cos. So it will be equal to 2, the sine of 3x plus x out of 2, the cos of 3x minus x out of 2 when we expand it. But they are telling us all that will be equal to 0. So we proceed and work on this, which will give us 2. The sine of this will be 4 out of 2, which is 2x. And the cos of 2 out of 2, which is x, is equal to 0. Once we get this, it is an AB condition is equal to 0. So we use the 0 rule. That if we take 2 on one of them, it stays there. This would imply that 2 sine of 2x is equal to 0, which ultimately implies that sine 2x is equal to 0, or cos of x is equal to 0. So for sine 2x is equal to 0, we shall get values of x. To get values of x, we can start with the 2x. If we are looking for 2x, it will be equal to the angle whose sine is 0. And since this is 2x, if we are looking for the angles, we shall multiply the given range originally by 2. So for 2x, the range will go to negative 360 to positive 360. And eventually we divide by 2 to get the x. So for 2x, the first value will definitely be 0. The next value will be 180. The next value will be 360. But normally, whenever you get these angles, like we have been seeing before, since the range involves negative angles, you try their negative equivalents. Their negative equivalents, in most cases, are in agreement with what we want for this case. That you will discover that these plus or minus will be in agreement with the range. The sine of negative 360 is also 0. So the values of x that are valid will be 0, will be plus or minus 90, and plus or minus 180. Now these are values of x for that first part. For cos of theta of x, equal to 0, x will be equal to the angles whose cos inverse is 0. And you start by trying to discover the first value. The first value of x here will be 90. If you check its negative cos of the negative of the same value, does it also give you 0? Yes, it does. Then we look for the next angle where the cos is 0. We try 270. The cos of 270 is also 0. You try its negative equivalent. The cos of negative 270 is also 0. So that becomes correct. If you try to move beyond here, you will go outside the range. Remember, the range is 180. Since this does not dictate, then we conclude and state that the values of theta of x, the values of x between negative 180 to positive 180 degrees will now be 0 degrees. And we start with negative 90 degrees, 0 degrees, positive 90 degrees, and then we can have negative 180 here, negative 90, 0, 90, and then 180. You can now present this as the final solution of that number over there, as the final solution of that number over there. So apart from the application of the factor formula, the reasoning is the same as the previous reasoning when we are looking for solutions. We can try out another example. We shall do 3 examples, and we will try to do as many examples as we possibly can to try out the miscellaneous, the exercise 17H and the miscellaneous one at a go, if we manage to. If we can't do that much, still you'll be able to try out what will be practically possible based on what we have covered. Example 2, they are saying solve the equation. Solve the equation, and the equation here is cos of x plus 20 degrees, the 20 is in degrees, minus cos of x plus 80 degrees is equal to 0.5. For x in the range of 0 degrees to 360 degrees. Let's solve that number over there. Solve that number over there. Notice that we are subtracting cosines. So you can always recall that cos of P plus cos of Q before you start is 2 cos P plus Q over 2 cos P minus Q over 2. Since we are, this is addition, but we are subtracting. You should quote the one that is relevant only. Minus 2 sine P plus Q over 2 sine P minus Q over 2. So one that is relevant is this one. So we are going to use that reasoning and say that the equation at hand gives us that cos of x plus 20 degrees minus cos of x plus 80 degrees is going to be equal to minus 2 the sine of x plus 20 plus x plus 80 all over 2, and the sine of the same. When we subtract, the x would go, because the space is not enough, I want to just put 20 minus 80, which will be minus 60 over 2. Okay? And when I do this, okay, I can repeat it for purposes of clarity. It is minus 2, the sine of, since this is clear, I can now write it as 2x plus 100 over 2. Then the sine of, this is x plus 20 minus x plus 80. Everything over 2. This gives us minus 2. The sine of, I can now write this as x plus 50 degrees. The sine of, now it is x plus minus x minus 80 over 2. I'm prolonging this so that we clearly see how it comes out. This will cancel, and we now have minus 2, the sine of x plus 50 degrees, the sine of negative 60 out of 2, and this gives us the sine of negative 30. It is minus 2, the sine of x plus 50, the sine of negative 30 degrees. And this is definitely equivalent to a half, because this is the left-hand side. But one thing you need to know here is that the sine of negative 30 degrees is equal to the negative sine 30 degrees. You need to recall that sine of minus theta is equal to negative sine of theta, and the cos of minus theta is equal to cos of theta. This one is a fact that everyone needs to recall. So if I substitute for this there, I'll have minus 2 times minus a half into the sine of x plus 50 degrees is equal to half. This minus will turn into positive, implying that we are interested in finding the sine, the value of x at positive a half. So our x plus 50 degrees will be equal to the arc sine of a half. And if we go back to our quadrant, or students taking coffee or chemistry, we are looking for angles here and here. And the first value that your calculator will give you will be 30 degrees. The next value you'll move up to 180 and take off 30 will be 150 degrees. Because the range given is 360, and we are going to be taking away 50 from each angle, we continue and look for the next angle. 360, we add on another 30, we get 390. We got 540. We take off 30, we get 510. This will be enough. So our x will give us negative 20 degrees, to give us 100 degrees, to give us 340 degrees, and it will give us 460 degrees. If we look at the range, we conclude and get the values of x in the range as 100 and 340 degrees only. The values of x in the range are 100 and 340 degrees. That is in the range of x between 0 . We have only two angles. So that is how these numbers are done. Just very simple. Just very simple. We can look at another example. I hope, my dear students, you're following. Now we can consider this as okay, we can consider it as the last example for today. I am sure you will be able to try out the next numbers. In our next lesson, we shall deliberate on the remaining examples. But we are going to try out two more examples. This is example 3. Example 3 and one more. Then you will be able to now do part of the exercise. Example 3, they are telling us to solve for x. Solve the equation. Solve the equation. They're telling us to solve the equation, and the equation is the sine of x plus 15 degrees into the cos of x minus 15 degrees is equal to half. For values of x in the range of 0 to 360 degrees. Every example we are doing is unique. This is now sine cos is equal to that. You should be able to ask yourself which expansion gives you sine cos, which double angle formula gives you sine cos. Which double angle formula gives you sine cos. In order to make it familiar, we introduce a multiplier of 2. A multiplier. In other words, multiply by 2 both sides, so that we write it as that plus 15 into cos of x minus 15 will be equal to a half times 2, which of course will give us 1. And now 2 sine x plus 15 degrees into cos x minus 15 degrees will now give us that. And at that stage, we can be able to come up with the original expansion. Since this is sine cos, and now I brought in the 2, it means it must have been an expansion of a sine plus a sine. This is expansion. It implies that it's an expansion of sine. When we add this, it will be sine of 2x. We add 2x plus the sine of the angle. When we subtract, it is 15 minus minus, which is that, should be equal to 1. This is the expansion of that. But when you put it at this stage, you remember that sine 30 is known as a half. So this gives us the sine of 2x as actually a half, because it will be 1 minus that a half. So it means that we can get the values of the angle whose sine is actually a half. And 2x will give us 30 degrees, 150 degrees. We already looked at this. The next angle will be 390 degrees, And since the range is that, and we are going to divide by 2, we can proceed. Go to 540, and we take away 30, we get 510. And we can proceed and go to 720, we add on 30, we get 750. I think we'll leave it at this. If we go beyond the other angles, we'll be outside the range. So the values of x will be 15 if we divide. 75 degrees, 100, 390 divided by 2, 195 degrees, 255 degrees, and 750 divided by 2 will give us 375 degrees. Looking at the range, we can do a final conclusion and say our values of x will be 15, 75, 195, and 255 degrees only, and 255 degrees only. These are numbers that a student should always find easily passable if they have understood the concept of double angles or use of factor formula. We can look at another example. This example now trains us or asks us to ideally look at some bit of proof. They are saying prove the identity. How do we use the factor formula to prove? The identity is that the cos squared of A minus the cos squared of B is equal to the sine of A plus B into the sine of B minus A. If they told us to prove this, I told you from our previous coverage that you choose a side. We are going to choose to prove the left-hand side, which is cos squared A minus cos squared B. And here we say using the difference of two squares, these are two square numbers. Using the difference of two square numbers, we can write this now as the cos of A, cos squared A minus cos squared B minus cos of B, we are factorizing, into cos of A plus cos of B. That's step number 1. Step number 2, when we are subtracting cos, we use sine. It becomes minus sine of A plus B over 2 sine of A minus B over 2 times 2. That is cos minus cos is 2 sine times, it's a multiplication, 2 cos plus is cos A plus B over 2 cos A minus B over 2. That is approach number 1. We shall have another approach. Which will actually be much shorter. From this, we can say that we join each corresponding the A plus B with the A plus B, and we get this as minus 2 sine A plus B over 2 cos A plus B over 2 times 2. This minus is there. Sine of A minus B over 2 cos A minus B over 2. As you work through this proof, normally your target is home. Home is what you want to get. From Double angles. Double angles. We know that sine A plus B as a double angle will give us 2 sine A plus B over 2 cos A plus B over 2. Specifically picked this to be relevant. So it means this first part is already the same as sine A plus B. What about this? So we can say if we apply that, we already have a minus, but of sine into A plus B already, times sine into A minus B. Now if I enter this minus here, I'll recall that sine of minus theta is the same as minus sine of theta, which I also quoted just a few minutes ago. So this minus here will be entered in the second bracket and say it is sine of A plus B times sine into minus A minus B. If we enter it there inside, it is going to give us our sine of A plus B into sine of B minus A as required. This is now equal to the right hand side. And we say hence proved, because what we have is now similar to that. I'll give you an alternative of that. Alternatively, they are saying cos squared A minus cos squared B should be shown to be equal to sine of A plus B into sine of B minus A. We can consider double angle. Consider cos of 2A. Cos of 2A is the same as 2 cos squared A minus 1. So you can make cos squared A the subject here. If we make cos squared A the subject, we shall get it as a half into cos of 2A plus 1. Similarly, it implies that cos squared B is also a half into, you can even write this as that, cos 2B. So left hand side could be substituted to look like a half into cos of 2A plus 1 minus a half into 1 plus cos of 2B. And this would definitely give us a half cos of 2A plus a half minus a half minus a half cos of 2B. This will definitely cancel. If I pick a half out, I will stay with cos of 2A minus cos of 2B. And I apply the factor formula. Applying the factor formula on the bracketed part, I will get a half. Cos minus cos is sine, minus 2, the sine of 2A plus 2B over 2, the sine of 2A minus 2B over 2. And this definitely will cancel with that 2, and I'll have sine of A plus B times the sine, I will enter this negative inside again, of A minus B, which will give me sine of A plus B into the sine of B minus A, again as required, which is equal to the right hand side, hence proved. So these things are possible. Ladies and gentlemen, I really want to assure you that these things are possible. We are going to take on one more example, which will be the very last one. And we are taking it on because it gives us additional capacity to try out numbers, specifically in the next exercise. example, I'll call it number 5. It should be more than the 5th example. They are saying solve the equation. Solve the equation. The equation is cos of 6x plus cos of 4x plus cos of 2x is equal to 0. And the range of x is 0 to 180. Yeah, the reason I'm taking this on is it is a unique number. As you can notice, it has 3 parts: cos 6x, cos 4x, and cos 2x. The interpretation here is you look at 6x, look at 4x, look at 2x, and see which one will be neutral. There will be a common factor. If you chose to expand this and this, since it is cos plus cos plus cos, we will look at one of these, 2 of these that we will expand and get one as a common factor. If I chose to use 6 and 2, it will give me a common factor of 4. I repeat, if I chose to look at 6 and 2, it will give me a common factor of 4. If I use 6 and 4, when I add, I get 10, I get 5x. When I subtract, I get x. There will be no common factor with this. So you look at the 3 given and choose 2 that you can play around with and get one as a common factor. And that means we can rearrange this as cos 6x plus cos 2x plus cos 2. We are going to apply the factor formula only here. When we apply it, we shall get 2 cos of 6x plus 2x out of 2 cos of 6x minus 2x out of 2. I'm using the same sum and same diff plus the cos of 4x is equal to 0. Hope we are together. If we do the mathematics, we'll get the cos of 4x now here, and get the cos of 4 out of 2 will be 2x plus cos of 4x is equal to 0. The cos of 4x becomes common, as you can clearly see. We pull it out, and this leaves us with 2 cos of 2x plus 1 is equal to 0. At this stage, we have successfully factorized, and we are going to apply the 0 condition. We are going to apply the 0 condition now, that either this is equal to 0 or this is equal to 0. So applying the 0 condition, the cos of 4x into 2 cos of 2x plus 1 is equal to 0 gives us that cos of 4x is 0, or 2 cos of 2x plus 1 is 0. So with 4x, we can get angles whose cos is 0. And the values will be, we have done this before. The first value, I think, is 90. And since we are looking at positive angles, we shall not look at the negative ones, but the negative 90 will also work. And the other value was, I think, 360. The other value was 270, sorry. 270. The cos of 270 is also 0. Remember, the range is 180, but since this is 4, we can go an extra mile. When we reach 360, we add another 90. So 450, the cos of 450 should also be 0. I believe you now know how we are doing it. The first angle is here, so we move 360, we add on the first angle. And when we move on again to 270, which would be here, it means that on our 360, we add on 270, we'll get 600 what? 30. 630. The cos of 630 will also be 0. We will leave it at that. So x will be equal to 22.5. I think 90 divided by 4 gives that. 270 divided by 4 will give us what? 67.5. 450 divided by 4 112.5. 630 divided by 4, 157.5. If I took up the next angle, it will be 810. 810 divided by 4 will give me 202.5, but this will fall outside the range. We discard this. If I look at another part, 2 cos 2x is -1. So the cos of 2x will be equal to -1/2. And we look for values of x for a cos of -1/2. Since we have 2x, we shall also try to go a little beyond double the range. The first angle whose cos inverse is negative 0.5 is 120 degrees. Why? Because cosine is negative here and here. And the next angle is going to be 240 degrees. The cos of 240 degrees should also be negative. If we move an extra mile, we come to 360. We add on another 120. That will give us 480. And then if my range is 180 degrees, I don't need to go beyond here because even this is outside the range. So my x becomes 60 degrees, 120 degrees, 240 degrees. So I can conclude and I merge these and these to state the values of x that are in the range. Beginning with 22.5 degrees, the next angle will be 60 degrees, the next will be 67.5 degrees, the next will be 112.5 degrees, the next will be 120 degrees, the next will be 157.5 degrees, and that will give us the values of x that are qualified for the range of this question. The values of x qualified for the range of this question would be those. If you are careful, you'll get all the angles. You will definitely miss out on some of the angles. I want to consider this as a very rich lesson and encourage you to study the next example, which we shall discuss in our next lesson. Our next lesson will still be on this. We shall discuss that example and, of course, look at selected numbers from exercise 17H and the miscellaneous exercise. The miscellaneous exercise has numbers you should be able to do, numbers that range from all the previous numbers we have been trying to do fall within the miscellaneous, including numbers that fall under what we have covered today. For now, and of course 17I. Those that you can manage. Those that you can't, please get back to me and we find out. I wish you the best. But for those that are preparing to attend my next lesson on schedule, take note that it is going to delay a bit. It should have started. It should be starting in the next 3 minutes according to my initial program. But because we have finished this late, we need to rest a bit and start it at 11 sharp. God bless you.